We were wrong about gold's origin. A cosmic revelation for thousands of years, gold has been a cornerstone of human civilization. It's adorned kings and queens, been used as currency, and symbolized power, wealth, and immortality. Yet, gold is more than just a symbol. It's a material with a story that dates back billions of years to the very origins of the universe itself. But what if everything we thought we knew about gold's origin was wrong? For the longest time, scientists believed that gold was formed in the fiery explosions of massive stars, called supernovae. This explanation seemed straightforward and fit well with our understanding of stellar evolution. But as science progressed, this theory began to show cracks. Recent breakthroughs in astrophysics, including the detection of gravitational waves, have revealed a far more complex and extraordinary origin for gold. This discovery not only changes how we view gold but also how we understand the universe and our place in it. Join us as we unravel the mystery of gold's cosmic origins, challenging centuries of beliefs and diving into the awe-inspiring processes that make this precious metal so unique. Chapter 1. Gold in Human History. A timeless fascination. Gold has captivated humanity since its first discovery. Unlike other metals, gold doesn't tarnish or corrode, making it a symbol of purity and permanence. Ancient civilizations revered gold, associating it with gods, immortality, and the divine. The Egyptians, for example, believed gold was the flesh of the gods, and it played a central role in their religious rituals. Throughout history, gold has been a measure of wealth and a driving force behind exploration and conquest. From the gold rushes that shaped the modern world to its use in cutting-edge technologies today, gold has remained indispensable. Yet, for all its significance, we rarely stop to consider where gold actually comes from. Why is it so rare? Why does it exist at all? The answers to these questions are hidden in the distant cosmos, where gold's story begins. Chapter 2. The traditional theory, gold from supernovae. For decades, scientists believed that gold was formed in the final moments of a star's life. When a massive star exhausts its nuclear fuel, it undergoes catastrophic collapse, resulting in a supernova explosion. In this colossal event, temperatures and pressures rise to unimaginable levels, enabling a process called process nucleosynthesis. This is where atomic nuclei rapidly capture neutrons, creating heavier elements like gold. The explosion then scatters these elements into space, seeding future star systems with the building blocks of planets and life. This theory was elegant and seemed to explain why gold, along with other heavy elements, is so rare. Supernovae are rare events themselves, and only a small fraction of the material ejected during these explosions would end up forming planets like Earth. For years, this explanation was widely accepted. But as our tools for observing the universe improved, scientists began to question whether supernovae alone could account for the amount of gold observed in the cosmos. Chapter 3. Cracks in the supernova theory. The first doubts arose from computer simulations of supernova explosions. While these simulations confirmed that supernovae produce heavy elements, they also revealed that the conditions for creating significant amounts of gold were less common than previously thought. Moreover, observations of supernova remnants showed inconsistencies in the expected abundance of gold. If supernovae were the primary source, we should see more gold in these remnants. But the data didn't match the predictions. These discrepancies pushed scientists to look for alternative explanations. Was there another cosmic event capable of producing gold on a larger scale? Chapter 4. The Breakthrough. Neutron star collisions. In 2017, a groundbreaking discovery revolutionized our understanding of gold's origin. For the first time, scientists detected gravitational waves from the collision of two neutron stars. These are the ultra-dense remnants of massive stars, each containing more mass than the Sun packed into a sphere just 20 kilometers across. When neutron stars collide, the resulting explosion, called a kilonova, releases an immense amount of energy and material. Crucially, the conditions in a kilonova are perfect for the process, making it an ideal environment for the creation of heavy elements like gold. The detection of this event confirmed that neutron star mergers are a major source of gold in the universe. In fact, a single neutron star collision can produce more gold than all the supernovae in a galaxy combined. This discovery not only solved the mystery of gold's origin but also highlighted the power of gravitational wave astronomy in revealing the hidden workings of the cosmos. Chapter 5. Gold's journey to Earth. Even with its cosmic origins established, the story of how gold arrived on Earth is equally fascinating. When our planet first formed, it was a molten mass of rock and metal. During this time, most of the heavy elements, including gold, sank to the core, leaving the crust relatively gold-free. So how did gold end up on the surface? The answer lies in a period of intense asteroid bombardment, known as the Late Heavy Bombardment. During this time, countless asteroids, rich in gold and other metals, struck the Earth, delivering these elements to the crust. This process not only made gold accessible for mining but also ensured its scarcity, as only a tiny fraction of Earth's total gold is found near the surface. Chapter 6. Implications of the new theory. The discovery of gold's true origin has far-reaching implications. 1. Astrophysics. Understanding neutron star collisions provides insights into the behavior of matter under extreme conditions. 1. It also helps us refine our models of the universe's chemical evolution. 2. Planetary science. The role of asteroid impacts in shaping Earth's resources highlights the interconnectedness of cosmic and terrestrial processes. 3. Mining and exploration. As we search for gold on Earth and beyond, knowing its cosmic origin could guide future exploration efforts, including on the Moon and Mars. 4. Philosophy and culture. Gold's extraordinary journey from the collision of neutron stars to its presence on Earth adds a new layer of wonder to this already fascinating material. It reminds us of our deep connection to the cosmos. Chapter 7. Gold beyond Earth. The quest to understand gold doesn't end on our planet. Scientists and space agencies are exploring the possibility of mining asteroids, which are rich in gold and other valuable metals. Such efforts could revolutionize our economy and reduce the environmental impact of mining on Earth. Moreover, studying gold on other planets and moons could provide clues about their history and the processes that shaped the solar system. For example, the discovery of gold deposits on Mars or the Moon could reveal information about their past asteroid impacts and volcanic activity. Chapter 8. The bigger picture. A universe of surprises. The story of gold is a testament to the power of human curiosity and the ever-evolving nature of science. It shows how even the most cherished ideas can be overturned by new evidence, leading to deeper understanding and awe. Gold's origin is just one of many cosmic mysteries waiting to be unraveled. As our tools and techniques continue to improve, who knows what other secrets we'll uncover about the universe and our place in it. Gold is more than just a metal, it's a cosmic miracle. Its journey from the collision of neutron stars to its presence on Earth is a story of unimaginable forces, billions of years in the making. This newfound understanding of gold's origin not only deepens its value but also inspires us to keep exploring the universe and seeking answers to the mysteries that surround us. So, the next time you see a piece of gold, remember, it's not just a material object. It's a piece of the cosmos, a relic of a celestial event that shaped the universe itself.